In this video we're looking at the three theorems that relate to tangents and circles. In the first theorem here, it's theorem 5. A tangent is defined as a line that touches the circle at only one point. So this tangent here touches the circle at point B. Tangents have a very important concept later on in mathematics in future years, but for now we talk about tangents to the circles. Now when we have a tangent, the point where it touches the circle, the radius line from that point to the center of the circle, will always meet the tangent at right angles. So if I move point B around, the tangent moves around, touching at point B. Wherever we put it, the angle remains a right angle. So that's theorem 5, that an angle between the tangent and its radius is 90 degrees. The second of the tangent theorems is theorem number 7. In this one here I have two tangents, and where they meet at this point here, point A, the point of intersection of the two tangents, so this is the tangent at B and this is the tangent at C, they intersect at point A. We find that those two lines have to be equal because they're both the radii of the circle. So BO is 4.24, OC is 4.24. This tangent line here meets the radius at 90 degrees, and likewise here. But what we notice is the line segment between the tangent point and the point of intersection, that those two line segments are equal. So in fact we have a kite here, the adjacent pair of sides are of equal length. Opposite angles are 90 degrees. If I drew a line segment from O through to A, we find that we have a pair of congruent triangles here now, both right angled. The three lines must be the same length. These two lines are the same, both radius. Those two segments are the same, and this is a common line to both triangles. Therefore we find these two angles are equal at point O, either side of the yellow line, and these two angles would be equal also. So lots of properties when we have these two tangent lines intersecting. Even scope for some Pythagoras problems there because of the right angled triangle, and there's the hypotenuse. We go on to the third of the theorems relating to tangents. It's this one about, it's called the alternate segment theorem. What happens here is I have a chord CD, that is a chord's definition is joins 2 points on the circumference of a circle. Now when I draw a chord, it splits the circle into two segments. This segment over here between C and D, and this segment over here between C and D. So there's a major segment and a minor segment. The angle formed by joining C to D via a point in the minor segment, in this case we call it point B, that angle there will be equal to the angle formed on the other side of the chord right around to the tangent. Now we know it's 90 degrees in between the radius line and the tangent, but this angle here will be equal to this angle here. So if I move point C around the circle, you'll see that the two angles will stay equal. Either side of the chord, either in each segment, this one is between the chord and the tangent is equal to the angle between on the other side of the chord in the alternate segment. So that's why it's called the alternate segment theorem. So it's also related to tangents. Okay, let's go to our notebook. And the first, I've got three examples here, one for each of the theorems. The angle between the radius and tangent is 90 degrees. So here we're told here STU is the tangent line at point T, and we're asked to find the size of the angle TOU. So the angle in here, so the part of the triangle. We know that this is a right angle because it's the tangent line, it's the radius at right angles, so it's 90 degrees, that's 26. So if I take both those away from 180, I get this angle here because we have a triangle. So first thing we do is we say O to U is a right angle, and then we say, so angle TOU is 180 minus the 90 minus the 26 equals 64. It's probably worth you putting a right angle there in your diagram. Let's go down to the next example. Tangents to a circle from an external point are equal. So this is theorem number 7, that this segment here of the tangent, this is the tangent at A, is 15 centimeters, and this segment here from P to T of a tangent, P is obviously a tangent point, they intersect at point T, so those two segments are equal in length, so x is equal to 15 centimeters because the two lines are equal. Let's go on to the third one here, about the angle between a tangent and a chord equals the angle of the circumference in the ultimate segment. Angle between a tangent and a chord, there's the chord, there's the tangent, and the angle we're talking about is around here, and is equal to the angle at the circumference, there's the circumference, so at point S in the ultimate segment. So we talked about that angle there in the ultimate segments on that side of the chord, so in there, so that's 93, then that angle down there must be 93. The two are equal. So in our notes we write angle RST, this angle here, is equal to angle RTN. If they're equal, then they're both 93 degrees. Thank you.